All right, here we go. This is problem number 15 from chapter 9 of the Halliday and Resnick book. So we've got this system over here. We are told that M1 is 0.60 kilograms, and we are told that M2 has a mass of 0.40 kilograms, and we're trying to find out a bunch of stuff. Okay? So question A asks us for the acceleration of the center of mass of the system. So here's the deal. So when we did forces, we learned how to find the acceleration of a system here. But we kind of cheated a little bit in that we recognize the fact that these two, objects here are tied together by a rope. And so the system is going to kind of accelerate this way, right? But it becomes nonlinear because the pulley is kind of just like bending your force, I guess, right? So I'm still going to use that method. Let's find the acceleration of the system. Okay, and what's going to happen is mass 1 is going to accelerate this way in the I direction, and mass 2 is going to accelerate this way in the J direction, but with equal accelerations, right? So, let's see what we got here. All right, so keeping in mind, our systems method that we learned before, the only force that's going to affect our system is the force of gravity pulling mass 2 down, and that force of gravity is going to be 0.4 times 9.8, so that's 3.92 newtons, right? So that means that the acceleration of my system is going to be net force over mass. And so we've got a force of 3.92 newtons pulling the whole system forward, and it's got a mass of 1 kilogram, right? Because 0.6 plus 0.4. So we get an acceleration of 3.92 meters per second squared, kind of this way, right? So now what we want to do is we want to find the acceleration of the center of mass. All right? Well, in class, we learned how to find the position of the center of mass. And we learned that we could do that by taking the mass of object 1 and multiplying it by the position of object 1, plus the mass of object 2 times the position of object 2, and dividing it by the total mass, right? Okay? For, however many objects you've got. Okay? Well, we also talked about the velocity of center of mass, and what we discovered was that, well, if you differentiate this position with respect to time, it gives you this equation, that the velocity of the center of mass is just very simply the mass of object 1 times the velocity of object 1, plus the mass of 2 times the velocity of 2, divided by the total mass, right? Okay, well, check it out. The same rationale gives us an expression for the acceleration of the center of mass. That's got to be the mass of object 1 times the acceleration of object 1, plus the mass of object 2 times the acceleration of object 2, plus however many objects we've got, divided by our total mass of all of our objects. Okay? So this is it. We're just going to use this right here, okay? But the trick here is vectors, okay? So here we go. Let me kind of clean up the space here a little bit. Okay, so what I did here is I moved, moved my equation up there, give us a little bit more space. All right, so here we go. So here's what we're going to get. So the mass of object 1 is 0.60 kilograms, and the acceleration of object 1 is 3.92 meters a second in the I direction, plus the mass of object 2 is 0.4 kilograms, times its acceleration is negative 3.92 meters a second squared in the J direction. Okay, and then divide that whole thing by my total mass, which is 0.6 plus 0.4, or 1 kilogram. So kilograms are going to cancel out, and we end up getting the answer that's there on the sheet. You get 2.35 I minus 1.57 J meters per second squared. Oh, sorry, I forgot my squared here, didn't I? Okay, so there you go. So there's your acceleration. Question B wants to know what's the velocity as a function of time. Well, if this is A, as in acceleration, then part B, to find the velocity as a function of time, well, V is just V naught plus AT, right? But our starting velocity was 0, so it's just AT. So it's literally just your answer to A times T, okay? Question C says sketch the path. Well, notice my velocity is, well, I guess, so my acceleration, let's see how we want to do this. So our acceleration is going to be, it's this, right? So it's 2.35 this way, meters a second squared, and 1.57 meters a second squared this way, and so our overall acceleration is this way. Wow, what is going on with this pen all of a sudden? There we go. So our acceleration is this way along this hypotenuse here, which I'm doing a terrible job of drawing. So since our velocity began at 0, we're accelerating this way. That means our velocity is going to increase this way, which means that we're just going to move in a straight line. So the center of mass is just going to kind of take a path that goes, whatever, our starting center of mass is going to be here-ish, right? And it's going to just kind of go this way in a straight line, okay? And then D asks you to find the angle of that straight path. So just use a little trig and find this angle. What would it be? Inverse tangent of 1.57 over 2.35. Okay, and it gives you 33.7 degrees below the horizontal. There we go.